Good morning, everybody from my side. So, lesson number 5 2, it's page number 112 of your books, Dynamic of Uniform Circular Motion. In kinematics, we know that we just talk about velocity and acceleration, but in dynamics, we talk about the force. So, the topic is same, uniform circular motion. We already know about the velocity and acceleration. If you guys remember in the last uh, uh, topic, we discussed about velocity is tangential and acceleration is there, but today we will discuss about force. So let me review about the force. In chapter number 4, we studied laws of motion. In laws of motion, Newton told us about the motion and its aspects. So second law of motion tells us that whenever you apply force on an object, object starts motion. It means acceleration is produced. So when force acts on the object, acceleration is produced. This acceleration is directly proportional to the applied force. If you can see, A is proportional to F, and it is inversely proportional to the mass. So on combining, we said that F is equal to ma. So force and acceleration both are in the same direction. This is very important point. So just for a review, Newton's second law, F is equal to ma. Wherever the force is there, acceleration is there. So force and acceleration are in the same direction. Now this thing you have to keep in your mind. I'm repeating one more time. According to Newton's second law, F is equal to ma. F and A are attached to each other. If force is there, acceleration is there. If acceleration is there, it means there is a force. Both force and acceleration are always in the same direction. Review of the first topic. We said that when object move in a circular path, we said that object is having a circular motion, and if it is moving with the constant speed, still its velocity will be changing. Why? Because its direction of the velocity will be changing, and we know that the velocity direction is tangential velocity. It's along the tangent. We discussed this thing. When velocity is changing, acceleration is there. So acceleration in the circular moving object called centripetal acceleration, we also name it radial acceleration, and mathematically it was equal to v square over r. And if you want to find velocity, we use v is equal to 2 pi r over t. And also number of oscillations in 1 second, our number of revolution in 1 second we call frequency. Time to complete one revolution was named as period, and we said that F is equal to 1 over T. This was something we already discussed in topic 5.1. Now, in topic 5.1, we said that object when it is moving in a circular path, this is the object that is moving in a circular path. We said that it is moving in a circular path, it is changing its direction of velocity, so acceleration is there. So whenever acceleration is there, it means there is always force associated with that acceleration. So we can say, according to Newton's second law, F is equal to ma. If an object is accelerating, it will must have a force on it. So that force which keep the object moving in a circle is called centripetal force. To find the value of this force is equal to ma, I remind you what was the acceleration of this object moving in a circular object. The acceleration was equal to v square over r. So if acceleration was v square over r, I will substitute the value here in mar. So what I will find? So force will be equal to F is equal to mv square over r. Just for a simple concern, I know I am a little bit quick. So let me stop for a moment and get back to the point. What actually I was talking about, I was saying that whenever you talk about that there is an object and object is moving in a circular path, so we said that acceleration is there. But Newton told us that whenever acceleration is in the object, it is because of the force. So it means that this object which is moving in a circular path, it has a force that keeps it rotating in a circular path. So this force is named as centripetal force. To calculate this force, I start with Newton's second law. F is equal to ma. So m is as usual mass. A is the circular motion's acceleration. So acceleration of the circular motion was v square over r. I substitute here, so it changes to mv square over r. So mv square over r is the equation for the object moving in the circular path. I was trying to tell that this is the object that is moving in a circular path. This is the object at this point. This is the object. When it is moving, you know that velocity is always along the tangent and it has the acceleration toward the center. So as I told you, wherever the acceleration is, force is also attached with the acceleration. It means this object is moving in the circular path because of some force. That force keeps the object in the moving circular path. According to Newton's second law, F is equal to ma. I am not writing this sigma sign. We know that it is F net. So if you use this sigma sign F, if you just write F net, both are same, or just for simplicity, I am using F only. So F is equal to ma. This sign means sum, this sigma. It is called sigma, and sigma mean, it is also called summation. Summation, sigma mean sum of all values, sum of all
Wow.
forces, you can say. So sum mean net. So you can say if there are more than one force is acting, so add them up, you will find net. So for this case, there is
Thank
only
you.
one force we are discussing. That's why I just put F is equal to ma. Okay, this is Newton's second law. F is equal to ma. But we know that according to circular motion, what is value of A? A is equal to V square over R. When I replace this value of A here in this expression, so I will find the force F is equal to M into V square over R. So this force F is equal to mv square over R is called centripetal force. What is this Fc or Fr mean? Fc means centripetal force. So I can define in my own way. I can say that this is the force that keeps, force which keeps any object into circular path. If you want any object to move in circular path, it means it will have a force that is keeping it into circular path. Fc, centripetal. As
Okay.
we use AC, centripetal acceleration, so Fc is called centripetal. Centripetal mean toward center. Okay, I was going to give you the example. When I use the word centripetal force, it means any object that is moving in a circular path, it has a force. For example, I have a rope and there is a mass attached with the rope and I am spinning that rope in this direction in horizontal motion. My hand is providing the centripetal force to the rope and the rope is having a tension in it. It is tensed, stretched. So this tension is the centripetal force provided by my hand. If I release during the motion, I'm moving it and I release it. Suddenly I release it. What will happen? Will it stay in circular motion? No. It will suddenly move away from that circular path. For example, at that point, when I was moving, I remove it at this point. So I remove it, it will suddenly go in this direction. It means that why it is moving away from circle now? Because the centripetal force that was provided by my hand is now removed. Or I am moving it, suddenly the rope or string cut by someone or it broke down. What will happen? At that point where the string is broken down, what it will go? It will not continue circular motion. It will move
Proceed.
away from the circular path. You got my point. So why object is moving in a circular path? Because of the force provided by my hand, because of the force in the string tension toward my hand. If that force is not there, I release it, it will suddenly move away. So centripetal force is always there if you want to move an object in a circular path, and the value of that centripetal force is calculated by Newton's second law. F is equal to ma, and we said that it is equal to mv square over R. This is the expression that we have to remember in our mind and we will use it in the calculations. Okay, let me get back to the point. Now what we found here, we said that whenever object move in a circular path, it should have this centripetal force or radial force. Here I use R. So if I use R or use C, same meaning. Radial force mean toward the radius. Centripetal mean toward the center. So it's the same thing if you use FC or if you use FR. Okay, centripetal force mv square over R is this. So what are the important feature of this centripetal force? The first feature, for uniform circular motion, velocity is uniform. What does it mean? If speed is constant, but still its direction is tangential. If you see this figure, at circular motion, we studied in previous topic that its velocity is tangential. Secondly, acceleration is always toward center. Yes, we know that. And Newton's second law told us the direction of the acceleration and direction of the force are same. So if you know the direction of the acceleration is towards center, it means direction of the force is also towards the center. These 3 points are very important for circular motion. For circular motion, velocity is tangential. For circular motion, acceleration is toward the center. Force is toward center. Fourth point is also very important, that force must be applied by the other object. What does it mean? I just give you one example. When I was holding a rope and rope was attached with some object, let's say stone, so I am whirling that rope. When I was whirling that rope, the centripetal force on that stone was keeping it to move on the circular path. From where that centripetal force came? From my hand. So the centripetal force on that stone or on that object which is circulating in a circular path is provided by my hand. So this point tells us the centripetal force must be applied by the other object. If you see this, as I give you the example, to swing a ball in a circle on the end of the string, you pull on the string and the string exert a force on the ball. Here the centripetal force that provides the centripetal force is tension in the string, and that tension is provided by our hand, by my hand. So it means the centripetal force is always from the other object. Now the question comes, it means that centripetal force is everywhere for any object which is circulating. So if Earth is rotating around the sun, there is no string. In that case, the centripetal force is there toward the sun, but that is not because of someone holding it. That force is because of, in that case, it's gravity. In other cases like moon or the earth, it is gravity. Sometime it may be normal force, sometime it may be electric force. From where electric force? For example, we study electron is revolving in its orbit around the nucleus. So electron revolving, someone is holding from the nucleus. So no, when electron is revolving, it means there is electrostatic force. Proton is inside the nucleus, electron is outside the nucleus. So proton is positively charged, electron negatively charged. So proton is, this positive and negative charge is providing electrostatic force. So electric force is keeping it, that electron in the orbit. So always, whenever object in a circular path, what we have to keep it in our mind, that when object in moving in a circular path, there is a centripetal force. This centripetal force can be Mr. Athar's hand. This centripetal force can be electric. This centripetal force can be gravity. The moon is revolving around the earth. There is no string, but gravity of the earth keep it revolving around the earth. Uh, when you send any satellite, artificial satellite around the earth for weather purposes, for war purposes, for telecommunication purposes, so many countries send their own artificial satellite in the space. So these satellites keep revolving around the earth because of gravity. Now there is a very big misconception about the centripetal force. Somehow some people say that when object is moving in a circular path, so there are two forces affecting on the circular object. What kind of two forces? They said that one force is centripetal force that keeps the object in the circular path, another is centrifugal force that keeps the object moving away. So centripetal and centrifugal force are balanced, so object will stay moving in a circular path. It's a misconception. there is no centrifugal force in the object. If you remember chapter number 4, we said that in law of motion number 3, there is action and reaction on the same object, action and reaction which are equal and opposite. So if you see, the action of the object moving along the circular path is the centripetal force provided by our hand. So the reaction will be uh, about the same line and same object. So we cannot say this is the centrifugal force. This is the action from our hand and reaction from the string to the ball. So action and reaction both are same in magnitude. So that keeps the object moving in a circular path. There is no outward force on the revolving object. For example, you are swinging a ball on the end of the string around your head like this. You feel force pulling outward on your hand. You can see if you have a heavy object and you are trying to move it, so you will feel that the object is pulling your hand too. As you are pulling the object toward the center, your hand is applying the force. Similarly, you will feel as you increase the speed, you will feel that something is pulling your hand. That pulling force is something we consider that centrifugal, but there is no centrifugal force. What is happening at all to keep the ball moving in a circle? You pull inward and string exert inward force on the ball, and ball exert an equal and opposite force on your hand according to Newton's third law. So as I am pulling, this is the action, and the ball is pulling toward itself, that is reaction. Until I will keep on keeping my providing the centripetal force, my hand will provide the centripetal force. That time it will have this reaction force. But as I remove my hand, there will not be any reaction force. It can be seen in this figure also. While you were moving, if there is a centrifugal force and ball reaches here, so this centrifugal force should move right opposite to your hand. For example, you are here, ball is here. So if there was a centrifugal force, it should move away straight. But when you release it, what happens? Ball, rather to move away, it moves toward the tangential velocity. It means there was no other force. There was only reactional force that stays only for the time when you were applying the centripetal force. As you remove the centripetal force from your hand, or the centripetal force is removed, that time reaction is also removed. So if the ball moves straight from here, then we can say there is another force. But ball is moving along the path, along the tangent, it shows that there is no centrifugal force acting on the ball. Okay, this was all the discussion about the centripetal force and its amount. F is equal to mv square over r. Let us quickly solve this example 5.3. This example 5.3 is related to centripetal force provided by our hand. Read it.
Okay. Force on a revolving ball, horizontal. Estimate the force a person must exert on a string attached to a 0.150 kilogram ball to make the ball revolve in a horizontal circle of radius 0.600 meters.
Okay.
The ball,
Can you tell me the data meanwhile?
okay. First, the mass is 0.150 kilogram.
0.150 kilogram. It means it has the specific unit. I don't need to change it.
Yep.
Okay. And the radius is?
The radius is 0.600 meters.
0.600 meter. So I have radius, I have mass. Now what I need? Estimate the force.
The ball makes two revolutions per second.
Okay, we will write it if we require. I don't think so we require for force, because if you remember, for force, what was the expression? F is equal to m v square over r.
Oh,
okay, I found for centimeter. Now F is equal to mv square over r. Can you please help me to substitute the values? Okay, and please, so everybody, I need you guys to solve with me. Use your calculators. So just substitute the values. M is equal to
0.5 kilogram.
0.150. Okay. V is. Oh, there is a problem.
Yeah, they didn't.
We don't have V. Okay, let me complete the data. What was given? 2 revolution per second. So they gave us time period. Either we can write frequency or we can write time period. So they gave us time period is half a second, 0.500 second. Okay, for finding the time period, for finding the velocity, you remember the expression was v is equal to 2 pi r over t. So let me find v first. So v is equal to 2 pi r over t. Just substitute the values for v first.
V
So we will
equal
find
2 pi
2 pi
0
times
0.100 over
r
0
is 0.6. Okay, over t
over
is
0.5.
0.5. Okay, give me the answer for v, please. 12 over 5.
Mr. No.
Pi, yes, sorry, pi.
Okay, keep it as it is because I told you last time that the answer that is not actually asked by the question, we will keep it as it is. So we will search for the final answer. So write this value of v. This value of v in the expression. So 0.15 is m. V is
Okay,
12 pi
12
over 5 squared over r is
over
0.600. Okay, now substitute the values. What is f?
14.21223034.
Oh, yes, Mr.
Yes.
14.21
Square.
Newton. Is 14.21 is suitable answer or we need to change it because it has 4 significant figures 1 2 3 4 and in the question 3 here 3 here 3 here and also 3 here. So what do you think?
Yes, Mr. We need to change it.
We need to change it to
14.2.
14.2 Newton. So much better answer is 14.2 Newton. What we did talk about for today's lesson, that's really important. First of all, we say that whenever an object is moving in a circular path, so there is a force associated with the circular motion. That force is called centripetal force. And mathematically, this centripetal force is mv square over r. Secondly, you have to remember these 4 points. What are these 4 points? The velocity for circular motion is always constant but tangential. Acceleration is there, that is towards center. Force is also associated called centripetal force. It is also towards center. This force is applied by the other objects. This force is not because of the object which is revolving. This force is about something. For example, if something is moving in a circle attached to the string, so force is from the hand. If something is moving around the earth like moon, that force is because of the gravity of the earth, not gravity of the moon. Similarly, if electron is revolving around the nucleus, so this force is electric force that keep it rotating. Also, there is no centrifugal force concept. We just said that the force that is provided by your hand has a reaction from that object. So as much as you have the force from your hand, so that much you will have the you will have the relation. So there is no centrifugal force. How to calculate? I told you how to calculate this force. So thank you so much, guys.